Okay, so let's come up with a possible rational root. So let's go with what are factors of 36? 1, 2, 3, 4, 6, 9, 12, 18, and 36. Hopefully I didn't miss anything. Now of 6 will be 1, 2, 3, and 6. Let me move. What's a little bit different about this problem compared to 1, 2, and 3 is that we can see that here we're supposed to have 4 roots, okay? And I'm not going to take time to write these all out unless I start to run into some difficulty. So I know, for instance, that 1 and -1 are possible rational roots. So I'm going to test 1 and -1. If they don't work, then I'm going to test 2 and -2. I forgot to bring a calculator home, so I'm doing this all without the use of the calculator and showing that you can as well. So we have 4, 3, 2, 1, and 0, so all places are here. Here's x to the 4th, to the 3rd, to the 2nd, to the 1st, and to the 0. So a little more space there. I'll do the same thing over here. 6. Now what happens if 1 and -1 don't work? Well, then I'm going to try 2 and -2, 3 and -3, and so on. Okay, D mama, drop down the first number, and we are multiplying to get 6. We're adding straight down to get a -23, and multiplying to get -23, and adding down to get 5. Multiplying to get 5, adding straight down to get 32, multiplying to get 32, and unfortunately, this is not 0. That means 1 is not a rational root to this equation. Let's try -1. D mama, dropping down the 6, multiplying to get -6, adding down to get -35, multiplying to get a +35. Oh my goodness, we're running into large numbers here. So I have 13 carry the 1, so 63, multiplying to get a -63. I got to come off to the side, 63 minus 27. So I have 13, remember I don't have a calculator here, so I have 13, this drops down. So this is 6, if that's a 36, multiplying to get, oh, this was a -36, keeping the sign of larger number, by the way. Multiplying to get 36, and it worked. Perfect. Okay, so what do I do with this? Well, just like before, I can see I'm going to write down these numbers. Okay, so it has no x's. So it's like x to the 0. Has 1x, has 2x, and has 3 x's. Okay, so first thing I'm thinking is these are pretty large numbers. And is it possible that I could factor something out? Like, would that make it easier? Maybe that's a possibility. If not, if I can't factor something out, like I'm thinking to myself, are all of these divisible by, let's see, we don't have 5, no 7, not 3. I think I just have to jump in here. So I'm going to factor out an x squared, and I would be left with 6x minus 35. Okay. Hold tight. Let's see if this is working. I may need to go back here and see if I can factor something out. Okay, then I'm going to put over here 6x minus 35 and ask myself, if I take 63 and divide it by 6, that's not working. Did I add something wrong here? This looks good, this looks good, this looks good. Let me put it on pause. I'll be right back. This is showing, actually I'm not going to put it on pause. I'm just going to work through my thought process. I can't come up with the number to multiply by 6x and have it work. Let me move this. Okay, back, just working through my thought process. So this isn't factorable by grouping. If you're wondering why, like if I take 6 and divide it into 63, it doesn't divide in evenly. It gives me some type of a decimal answer. So there's nothing I can take times 6 and that being a nice integer answer and come up with 63. Doesn't mean that we can't solve this, but what it does mean is this isn't going to be factorable by grouping. So what do? Well, I tested 1 and -1. Now I'm going to go back, oh, my pencil. I'm going to test 2 and -2, 3 and -3, and see if I can continue to use synthetic division as a way to solve here. Okay, so the largest number is 3, so I have 3, 2, 1, and 0. And I'm going to be kind of lazy here, so I'm going to put in these numbers. The coefficients is 6, 35, 63, and -36. And now, again, I've tested 1 and -1. Didn't work. I'm going to test and try to be neat about this. I'm going to test 2 and -2. If they don't work, then I'm going to test 3 and negative 3 until I find one that works. As I will continue to use right now the synthetic division. Okay, here we go. Let's test 2. I'm going to write down really softly so I can erase it. I don't have to continue to write this little template here. Drop down, D mama. I'm going to multiply to get 12. Testing my mind here. So that'd be 25, negative 23. I'm going to multiply to get negative 46. There are different signs here, so 56, I'm going to come off is what? Is that 7? Is that 17 there? Let me just do my little quick little math. 13, that is. Okay, so this is 17 subtract. I'm going to take 17 times 2, should get 34, add down is negative 2. So I tested 2, 2 doesn't work. So I'm going to erase this down below. And I'm going to test negative 2. Okay, test negative 2. Drop down. Here we go. So 2 times negative 6 is negative 12. Combined to give you negative 37. Oh, 37 times 2. Is that 74, I believe? I believe that's 74, and it's a positive 74. Oh my goodness. So I'm adding these together, and I have 7. So I have 137. Now, I can already tell this isn't going to work. Watch this, because if I take negative 2 times 137, I'm going to have this really large number. And I add this really large negative number to another negative number, I'm not ending up with 0. So I'm going to erase it again. I'm really hoping that 3 or negative 3 work, or I'm going to have to write this template again. It's starting to get sloppy. Let's try 3. Dropping down 6. Okay, multiplying to get 18. So that's going to be, I believe, a 17 when I subtract. So the larger number is negative. All right, then I'm going to multiply. I believe that's a negative 51. And I combine to get 12. I multiply to get 36. And guess what? It works. Okay, so what does this mean? Of these different solutions, I know one of them is x equals negative 1. Right? The output is 0. I know another is positive 3. And now it's wonderful when it's down to just 3 numbers, because now we have this trinomial, and we can see that the largest degree is going to be a 2. So no x, 1x, and 2x. So I'm going to see, can I solve by factoring? 6 times 12, 6 times 12, oh my goodness, 6 times 12 I believe is 72. I believe I'm right here. 6 times 12 is 72. Okay, we're good. And combines it gives negative 15. Oh my goodness, what could this be? Well, when I think 72, I think 8 and 9. And if 8 and 9 are both negative, they multiply and they combine. Now, because the leading coefficient is not a 1, 6x squared plus 12 equals 0. I'm going to drop in negative 8x, a negative 9x. And now I'm going to use factoring by grouping to see, can I solve using this method? I can factor out at most a 2x squared. I'd be left with 3x minus 4. Make sure as I'm rushing through this in the video, I'm not making a mistake. There's 6x. So, it should be just 6x. 6x squared and minus 8x. Perfect. 3x minus 4. What times 3x gives us a negative 9x? Would be a negative 9. Perfect. And a positive 12. Perfect. Okay. So they both contain a 3x minus 4. In the front is a 2x, and the back is a negative 3. I'm going to take each one of these factors, I'll set it equal to 0, and I'll solve. One answer then will be positive 4/3. The other answer will be a positive 3/2. So we have 4 solutions to this polynomial equations. Negative 1, positive 3, positive 4/3, and positive 3/2.